So for your warm up, the expression 12T plus $2.50 represents the cost to purchase tickets for a play, where T is the number of tickets. Be prepared to explain your response to each question. So if a family paid $62.50 for tickets, how many tickets were bought? A teacher paid $278.50 for tickets for her students. How many tickets were bought? Be able to tell me the answer and how you got it. Table 1, what did you get for number 1 on the warm-up? A family paid $62.50 for tickets. How many tickets did they buy? 5 tickets. Anyone else get something other than 5? Okay. So, table 1, can you tell me how you got that? Did you like set up an equation? Did you guess in chat?
Well, is it right?
It is right. Okay. Did you? So there's the different ways of solving this is a key thing today. As long as you get the right answer at the end of the day, how you solve it is up to you. So did you like set up an equation? Did you just know to subtract 250 and then divide? Okay, so that was mentioned earlier as well. They knew that they had to subtract 250 first. From what remained, they divided it by 12, the cost per ticket, and that's how they got that. Did anyone get it a different way? Because although that's the right answer for me, I just, like, how do you know to subtract first instead of divide? So here's what someone else said when I asked them. They said that they really knew their multiples of 12. So they knew that 12 times 5 gives you 60, and then plus 250 matches our answer. So another good way of solving, me being a math teacher, my way of solving would have been to set it equal to the total, that's what they paid. This expression tells me like what their purchase price would be. If this is their purchase price, I would put it here, and then I would see, okay, this is just a 2-step equation. You always start with what's farther from the variable. So that's why you do subtract 250 first. And then opposite of multiplying by 12 is dividing by 12. I just really like structured processes that work every time, but all of these give you the same answer, I think. Questions on that? Okay, table 2. A teacher paid $278.50 for tickets for her students. How many tickets were bought? 23. Did anyone get something other than 23? All right, table 2, how did you get 23? And did you like set it equal, or did you do it like how big did it have to be?
Yes.
Okay, which again is the same steps we would have done if we set it up like this, same exact step. And it is the right answer, it is 23. Again, my suggestion, you set up the equation and solve, but that is a good way to also get the right answer, to be able to problem solve your way through it. Earlier, someone said that they guessed and checked 23. That they plugged in random numbers for the tickets, for the T, until they got their right answer. And of course, like adjust your answer from that. If they plugged in 30 and saw that that value is way higher than this, then they know to pick a number smaller than 30. If they plugged in 20 and they got that their answer was like smaller than this, then they know to pick now between 23 and 30. So they guessed and checked and got the right answer. But those are correct. Any questions? So you might be wondering why it was this easy. Usually the warm-ups lead to something else, like a key thing that you're supposed to notice. And this is our first lesson of unit 7. So unit 6 was introduction to quadratic functions. Unit 7 is quadratic functions. If you really understood the last unit, great. If you didn't understand the last unit, you're going to see a lot of the same stuff. And you have up until the next unit test to come and retake, do corrections, and you already all retook it once. But like to do corrections to try to improve your grade, and then maybe retake for full points after you've done that. Remember, I have tutoring Tuesdays now for the rest of the semester. If you are not happy with your grade right now, then that is what you need to do. We only had 3 unit tests this semester. We have 1 more scheduled for May 9th. So that's pretty far away. I mean, like a month away from now. Your grade's not going to change much unless you come to tutoring to remediate those lower test scores. And then you have another 150 assessment points going in May 9th. And a small window of time to retake it. Because school ends the 23rd. So I have a planned retaking class, just like I always do, for May 14th is when I have it planned. And then after that, we're reviewing for finals, taking our finals, and then you're done with your 9th grade. Done. Hopefully. If you end up failing, then you take it again. So there's that. Definitely, like, we're on a new unit, make sure you're saving your notes, make sure that binder check will go in as 100% when that comes. Some people have managed to like procrastinate and then get by just fine toward the end. There's really no more room for procrastination, like we're at the end of the year. So like, you can't just put it off until later. You have a small window of time to like study and do better for the retake. So just do better the first time and not even have to worry about that. All right, so today's lesson is actually a combo lesson. Both of them are a bit of review. And today it's solving some quadratic equations, knowing the meaning of a solution in context of a situation, writing quadratic expressions to represent situations, recognizing the factor form and standard form of quadratic expressions and know when it's useful for solving. And then using a graph to find the solution, but also knowing its limitations. So something that we are still deciding as math teachers is whether or not we will let you use graphing on this next unit test. There's pros and cons for each decision, but basically the last unit was all about graphing. This unit is all about how to solve with these other methods. So just know, like, a decision hasn't been made yet, but like graphing can't be used for everything. There's going to be questions on your test that a graph will not help you. So, and there are some that you just have to do without graphing, otherwise, like, what's the point? But we'll see. I'll let you know as soon as we make that final decision, but just know, like, you don't necessarily always get graphing calculators on your tests. But I'll let you know. I'm recording right now. It will be linked in the slides. You have 2 separate puzzle pieces, but they're both pretty short. Like the first one is 3 questions. So shortened. This will probably be one of the last times I mention this because I've talked about it a lot. If your grade went down these past 2 weeks when we were doing ACT Aspire Prep and you want to remediate those scores, because a lot of it we just can't do again. Like, I can't necessarily give you the practice test again. Like, you know, we can't necessarily make up those points, but this could be a way that if you lost points, you do this and I'll add those points back. Or you could just do it for fun, get some extra credit, and I'll put in the assessment category if you already had hundreds you have to use. Okay, but that's an option for you. And I already mentioned this, you will have like maybe 1 or 2 quizzes this unit. I never worry about quizzes. I'll let you know when they are and what lessons they cover. Otherwise, like, I don't anticipate these other dates changing. So any questions? So let's see, back to the notes. I mentioned this before, but these questions, I do think you all should be able to answer based on what we learned from Unit 6. You just might have to like dust off those problems. So here it is. A mechanical device is used to launch a potato vertically into the air. The potato is launched from a platform 20 feet above the ground with an initial vertical velocity of 92 feet per second. This function models the height of the potato over the ground in feet, t seconds after the launch. Here is a graph representing the function. For each question, be prepared to explain your reasoning and mark on the graph where you found your answer. Again, have group members to like share your answers with and make sure you're doing them right. I hope I don't need to assign reporters, but I absolutely can if I see that like, you know, other people need to step up to the plate. But I think you all can answer this. So since it's 4 questions, I'll give you 4 minutes. And then I'll call on. What is the height of the potato 1 second after launch? Okay, a little over 90 feet. What is this tick mark that I'm pointing to with my mouse?
100.
Okay, and also, table 4, I meant to ask you, how did you find your answer? Like, where did you look on the graph? Okay, good. So this is where you'd mark where you found your answer to number 1. It is a bit below the 100. It's not the 100 exactly. Definitely over 90, although it's like not perfectly halfway in between the 80 and 100. So I would say approximately whatever your guess was, maybe it's like 90 to 100. I'd probably lean closer to 100, but it's right below. So approximately 100 feet. The exact answer is 96, but that's all we can see from the graph, the way that it's numbered. Table 5, 8 seconds after the launch, will the potato still be in the air? And where did you look on the graph for that answer? On the 8-second mark. So this is time in seconds. Here's the number 8. The line is not there. Okay, so it is not in the air. It already hit the ground. So that this is where you mark where you found your answer for number 2. Table 6. Will the potato reach 120 feet? Yes, and then when did that happen? Between 1 and 2 seconds. Where on the graph did you have to look for that? Okay. So you probably looked at the y-axis first and then where it touched, but yes, I see what you're saying. It touches here, which is between 1 and 2. It might even look exactly at 1.5, so you could say approximately 1.5 seconds, but definitely between 1 and 2. Exactly, it's hard to tell. Approximately 1.5 seconds. Table 7, when will the potato hit the ground? Approximately 6 seconds. Approximately 6 seconds. Because again, it doesn't look like it's touching it right in the center. So that's why we're including the word approximately, because I'm abbreviating right now, but approximately 6 seconds. Okay, now that's the nice thing about graphs, and also where you look was here for that answer for number 4. For number 3, we looked here where that green dot is. But that's the good thing about having graphs and graphing technology. There are some limitations, like unless I pull it up on the computer and type in that equation, I can't see exactly what it's touching. And like I mentioned before, you might not have graphing technology on this kind of test. So just be able to fully understand the other ways that we're going to show you throughout this unit, not just rely on graphing technology. So use this knowledge that you just gathered for this next activity. So here is the function modeling the height of a potato in feet p seconds after being fired from a different device. So notice it has a different equation now. It still starts with negative 16t squared, because in the last unit, we saw that that comes from gravity and kind of projectile motion. But anyway, what equation would we solve to find the time at which the potato hits the ground? And then without graphing, find a solution to that equation. To do that with your groups, I'll give you about 3 minutes. So you can use Desmos, just don't use the graphing part right now, because then that's a piece of it. Write the equation to find when the potato hits the ground and solve that equation. Think about like the warm-up, how we solve things before.
So what equation, that means that your answer should have an equal sign because equations have equal signs. What equation would we solve to find the time at which the potato hits the ground? So they give you an equation. Let's kind of analyze that. What do the variables mean in this equation? Table 7. Okay, T is for time in seconds. Now, table 7, what's the F of T representing? Okay, good. So if we want to know when the potato will hit the ground, what's the height of the ground? Okay, that's the 64 is actually the starting height, like where, like how high it was launched from. If I want to know when the potato hits the ground, class, what would the height be at the ground? 0. Now, am I going to plug in 0 for the T or for the F of T? For the F of T. Because T is time in seconds. That's what we're trying to figure out. At what time did it hit the ground? F of T, which this is function notation, remember that this is representing the output, is my height in feet. So at the ground, my height in feet is 0, and they gave us this expression. This is the answer for number 1. This is the equation we are going to use to find the time that it hit the ground. Now, is this equation as easy to solve as the ones that we set up in our warm-up? It's not, because there's 2 different variables. Well, they're not different, they're both T's, but they're not like terms. Like I can't combine them, I can't isolate both of them. During this unit, we'll teach you ways to, but for right now, at what you're limited to, it's either like guess and check or isolating the variable, which I told you isolating the variable won't work. So we're left with guess and check. Did anyone get the answer? Jack? Okay, 5.7. Did you do it without graphing? Okay. Did anyone get this without graphing? Cause that was the thing, you might not have graphing on your test. You can disable the graphing part of your Desmos. Okay, so here's what you could do. And granted, I mentioned I'll show you a bunch of different ways throughout this unit to solve it without graphing, but for right now, at our level of knowledge, all we can really do is guess and check. So I'm gonna type in the equation, so I'm not using the graphing component. That's the whole thing, we're not using the graphing component. I'm just using the calculator part. So think typically like, how long would an average potato stay in the air for? You think it'd stay in the air for like 10 seconds? The potato? Or is that like too long? Okay, so you could guess and check and you could try the number 6, plugging it in for the T. When we get to where the answer is 0, that's when we found the answer. That would be like the ground level. So when I type in 6, it's at -32. So that tells me that I need to make what I'm plugging in smaller or bigger. Because at -32, say that my line looks something like this. -32 would be like here, so like below ground level, and that would have made sense for them. So should the number that I'm guessing and checking, should I make it bigger or smaller? All right, so maybe, then that's pretty close to 0, so maybe I'll make it smaller by 5. And don't forget to both parts that you plugged it in. Now that's above ground. So I know that my answer is gonna be somewhere between 5 and 6. Let's try 5.5. All right, when I try this number, it's still a bit above the ground, so I know I need to get like even a little bit higher. And yes, the closest we could get was 5.7. Was the closest we could get to 0. So there's answer, I think, is actually like 5.702. But this was the closest we could get using the guess and check method. So you could round that to about 5.7. Assuming you don't have graphing terminology, this is how you can do that. So 5.7 seconds using the guess and check method. Questions on that? Okay. We are going to skip the revenue from ticket sales. And I'm gonna have you look at the lesson synthesis. Because the main goal of this lesson is to kind of like observe everything that's happening. In this lesson synthesis, you're going to reflect on these questions yourself. You can talk to your groups if you want, but also make this adjustment. On number 3 of your lesson synthesis, you need to write in equals 10, otherwise it doesn't really make sense. So fix that on your paper right now. So it says, what are some limitations of solving this equation by guessing and checking? And then what about graphing? So give me some limitations, some like negatives about each method that we saw from today's lesson. Then in number 2 and 3, you are deciding, it's more of an opinion. Which equation do you think is easier to solve and why? So we'll pick one and then just be able to tell me why you think that one. Not asking you to solve it right now. Which one do you think is easier? Since we are pretty ahead in the lesson, I'll give you 5 full minutes to fully reflect on these. Should you finish early, do take out your Chromebook and start the practice. It's two separate ones. But don't do that until you fully answer it, because then we're losing that whole like lesson, which is not reflecting. 5 minutes starting now. We're gonna have a group discussion about this now, because this is the main point of the lesson. I know it didn't seem like we did much, but there are very key points going on. So in the first question, what are some limitations of solving negative 2x squared minus 2x plus 40 equals 10 by guessing and checking? So what are some limitations of the guess and check method? Jack? Okay, only works when you have a number to guess, so only works for equations, not like expressions. I guess that kind of goes for like any situation. You can't solve for the variable unless it's equal to something. Harley, you have anything? You might not be able to get exact number, so if answer is a decimal, then it's kind of a pain, like you have to keep altering your, numbers that you're guessing, and then if your answer is actually a decimal, like the answer was 5.702 earlier, like how would I know to plug that in? Any other ones anyone wants to share? All right, and it can be kind of tedious, but it does work at times, guessing and checking. What about graphing? What are some limitations with graphing that we've seen? Like maybe when we did the first page. Pardon? So same thing, we cannot see exact numbers sometimes. Like you have to estimate it. If they're printing a graph for you, like you're not able to click on it, that might estimate your answer. Any other limitations you guys think about? I would just add in, like, you might not always have graphing technology. One question on your Illuminate test. That I saw says specifically, without using a graphing calculator. And there are ways that we can make it to where that question only doesn't have graphing on it. But like, if you bring your own graphing calculator, there would be nothing stopping you from also using graphing on that question. So that's why we even started thinking about, well, should we let them use graphing calculators or not? So that's why I'm like putting it at the forefront of your mind, like just pretend as if you're not, so that you're not just relying on that only. But now for questions 2 and 3. These are more so opinions. So hopefully you picked one. Which equation do you think is easier to solve? Raise your hand if you chose the first one. Raise your hand if you chose the second one. And that's what I noticed earlier too. Why do you guys think the second one is easier to solve? Harley? It looks more familiar. What form is this on the right? What do we call it when it looks like that? Factor form. And then if it looks like what's on the left, what do we call this? Good try. It kind of is true, but standard form is what we call it for the quadratic equation. So we mostly in the last unit showed you that you could identify your x's, your zeros, if it looks like this, if it's equal to 0. So if I have two things being multiplied together to equal 0, what must one of those numbers be? Say it again. If I have two things multiplied together and it equals 0, what must one of those numbers be? 0. So that's why we actually can solve this one when it's in this form. Because all I have to do is figure out what value of x will make this parentheses 0. And then what value for x will make the other one 0. That's why most of the time there's 2 solutions for these. Because x could be -5. And that makes one of the parentheses 0. Or x could be, and this one takes a little more steps, but I would have to subtract 8 on each side, divide -2 on each side. But to make this parentheses 0, x could be 4. So that's why there's 2 solutions. When it's in standard form, I could do guess and check, so it's not impossible. But we saw the limitations of guess and check. And we solved when it's in factored form before. But now look at how they changed it in number 3. What's the difference between these equations and the equations in number 2? Table 9, can you tell me? What's the difference between these equations and these equations? They look identical except for what? They're all on the equation. Okay, good. These equal 0, these equal 10. Otherwise, the rest of it's exactly the same. So now when it's equal to not 0, and it's equal to a different number, raise your hand if you think this first one's easier to solve. Raise your hand if you think the second one's easier to solve. And again, that's your opinion. I can't necessarily say your opinion is wrong, but I know at least this one, I could do guess and check. For this one, we don't have like a rule for if something multiplies to give me 10, one of those numbers must be this. Like, you don't have a rule for that. There's lots of different ways that you can multiply to get 10. Like you can do 2 times 5, 10 times 1. You can even do decimals, I'm sure, of some sort. This one I think would actually be very hard to solve when it's equal to something other than 0. But again, that's your opinion. I can't tell you your opinion's wrong, but when you see that on your homework, think about what you just talked about there. Okay, so that still gives you a good amount of time to especially get the first practice done. The first practice is only 3 questions. And maybe even finish the second. If you have any questions right now, feel free to ask. If that is what you are doing, right? Kayla?